This is section 10.2, part B, arithmetic sequences and series. The first differences of sequences are found by subtracting each term from its successive term. When the first differences are all the same, the sequence is an arithmetic with the nth term can be modeled by a linear function of the form a sub n is equal to d times n plus a sub 0, where a sub 0 is the initial term, value d is the common difference. If the first differences are not the same, the sequence is not arithmetic. However, the differences may still help to identify the type of function that can be used to model the sequence. Consecutive first differences may be subtracted from one another, thus producing second differences. If the second differences are constant, then the nth term of the sequence can be modeled by a quadratic function. This function can be found by solving systems of equations. So we need to find the quadratic model for the sequence of 12, 20, 30, 42, 56, and 72. So if we write those terms again, we can see that to get from 12 to 20, we need to add 8. To get from 20 to 30, we need to add 10. Then we would add 12, 14, and 16. And as you can see, those differences are not the same. But if we find the second differences, so to get from 8 to 10, we added 2. To get from 10 to 12, we added 2. 12 to 14, we added 2. And 14 to 16, we added 2. So those are the second difference. Now, to write a second difference equation, we're going to use the quadratic equation that says a sub n is equal to a times n squared plus b times n plus c. So if we plug these in for the first term, so the n will be 1. So a1 is going to be a times 1 squared plus b times 1 plus c. And we know that that a sub 1 was the first term in our sequence is 12. Or if we simplify this, 1 squared will give us 1a plus 1b plus 1c is equal to 12. We know for a2, we're going to have a times 2 squared plus b times 2 plus c, and we know our second term is 20. So if we simplify this, 2 squared gives us 4a, 2 times b is just 2b plus 1c is equal to 20. Since we have 3 variables, we have a, b, and c, we are going to have 3 different equations. So if I do a to the third, a sub 3, that's going to be a times 3 squared plus b times 3 plus c, and we know our third term is 30. So this gives us 9a plus 2b plus 1c is equal to 30. Now that we have this in the form, we can put these into matrices. So our matrix A would be 1, 1, 1, 4, 2, 1, and 9. This should be a 3, not a 2, because 3 times b gives us 3b. So it should be 9, 3, 1. We know that matrix B will be the solutions. So it'll be 12, 20, and 30. And to do this, you can do the inverse of A times matrix B. And you will get from our matrix for our solution 1, 5, and 6. So that means A is equal to 1, B is equal to 5, and C is equal to 6. So if we write our equation, We're going to come back and we're going to substitute them into here. So I'm going to have 1n squared plus 5n plus 6 as the equation for our sequence. If calculating second differences does not result in a constant difference, higher degrees may be found. This process is similar to the process needed to find a quadratic equation. The function that will model a sequence is dependent on how many computed differences are necessary before finding a constant difference. So if it's the first degree, or first one that's the difference, it would be linear. If it's the second difference that works, then it'd be quadratic. Third would be cubic. Fourth would be quartic. And the fifth difference would be quintic. Higher differences may never result in constant differences. In this case, there may not be a polynomial model that can be used to describe the sequence. So we're also going to look at arithmetic series. An arithmetic series is the indicated sum of a term of an arithmetic sequence. So the sum of a finite arithmetic series with n terms, or the nth partial sum of an arithmetic series, can be found using one of two formulas. So you're going to determine which formula you need based on which information you are given. If you know the first term and the last term, and you know how many terms there are, you'll use formula 1. If you know the number of terms, and you know the first term, and you know the common difference, then you will use formula 2. So find the indicated sum of each arithmetic series. So on the first one, we know the first term, we know the last term. So we can find our values. First, we're going to have to find which term it is because we don't know the value for n. So we can start with a sub n is equal to a sub 1 plus n minus 1 times the common difference. Now, to get from negative 5 to 2, they added 7. To get from 2 to 9, they added 7. So our common difference is going to be 7. We know our last term is 317. We know our first term is 5. We're going to have to solve for n first. So this will give us 317 is equal to negative 5 plus 7n minus 7. If we take the 12 to the other side, we are going to get 329 is equal to 7n. And if we divide both sides by 7, we'll find out that n is equal to 47. So we do know there are 47 terms. So now we know the number of terms, we know the first and the last term. So we are going to use the form of s sub n is equal to n over 2 times a sub 1 plus a sub n. So we are finding the 47th, sum of the first 47 terms. So it'll be 47 over 2 times negative 5 plus 317. And if you put that all into your calculator, you're going to get the sum of the first 47 terms will be 7,332. Now we need to find the partial sum for the 28th partial sum. So we do know our first term. We can find our common difference. So we are subtracting 13 here, or we're adding a negative 13 to get to here. We know it's the 28th term, but we don't know what that last term is. So we're going to use the other formula this time. We're going to do s sub n is equal to n over 2 times 2 times a sub 1 plus n minus 1 times the common difference. So if we're finding the 28th term, we're going to do 28 over 2 times 2 times our first term, which is 27, plus n, we know it's the 28th term, minus 1, times our common difference, which is negative 13. And that's going to give you a sum of negative 4,158. Now on part C, you can do this one by hand, or you can just put it into your calculator. So remember, if you need to put this into your calculator, let's clear our screen. We are going to hit Math, and you're going to go down until you find option 0, which is summation. We are going to do x equals 6 until it equals from 6 to 28. And then we're doing 5x minus 17. And that will give us a sum of 1,564. A video game tournament in which gamers compete in multiple games and accumulate an overall score pays the top 20 finishers. First place receives $5,000, second place receives $4,800, third place receives $4,600, and so on. How much total prize money is awarded? So we can find the common difference. Our common difference is the price, or the award amount, goes down 200 each time. We know that our n value is 20 because we're paying the top 20 people, and we know that our first term is 5,000, but we don't know what that final term is, so we are going to use the second option. So if we're paying the top 20 players, we're going to do 2 times 5,000 plus 20 minus 1 times our common difference of 200. And that means if they pay the top 20 players, the amount of prize money needed would be $62,000. Carter has been collecting baseball cards since his father gave him a 20-card collection. During each month, Carter's father gives him 5 more cards than the previous month. In how many months will Carter reach 1,000 cards? So we know that we're finding the sum. We know that the sum is going to be 1,000. We don't know how many months it's going to take, but we know he's going to start with 20 cards. And we know that he's going to get 5 new cards each month. So to get rid of this 2 in the denominator, we can multiply both sides by 2. So we'll have 2,000 is equal to n times 2 times 20 gives us 40. If we distribute this 5, then we're going to get plus 5n minus 5. If we combine like terms, that's going to give me 35 plus 5n. Now we can take this n and we can distribute it to both parts. So we have 2,000 is equal to 35n plus 5n squared. Since we have an n and an n squared, we are going to end up having to factor. So we can take everything to one side first. If we want to move this 2,000 to the other side, we are going to have to make it negative. So we're going to have 0 is equal to 5n squared plus 35n minus 2,000. Now to make the calculations a little bit easier for us, we can go ahead and divide everything by 5 to get that n by itself. And we're going to end up with n squared plus 7n minus 400. Now, there's nothing we can factor to get whole numbers, so we are going to have to use the quadratic equation. Remember, the a value is what's in front of n squared, the b value is what's in front of n, and the c value is the part that's by itself. So we're going to have negative 7 plus or minus the square root of 7 squared minus 4 times 1 times 400 negative 400 all over 2 times 1. And if you do those calculations, you're going to get n is approximately 16.8, or n is approximately negative 23.8. Now, it's not possible that we have a negative amount of months, and we want him to have a total of 1,000 cards. So that would take until the 17th month